right, so we're starting Unit 2 today. Today is super duper short. Just going to get you into the idea of solutions and electrolytes and talk about strong, weak, and non-electrolytes. Most of our solutions are going to be water-based solutions, which kind of makes sense. Let me check my pen. Is my pen working? There it goes. So using water in drawings is a very, very common thing that shows up on the AP, to the extent where you're even having to turn water and align it the appropriate way, right? Did y'all see the water spill outside? Yeah, it was pretty dangerous out there. So this is an ionic compound, and we know that because we have positive and negative charges. Can you all see that on your papers? It's hard to see on this. And so if you write on desks, I make you stay and clean all the desks. Okay, cool. Positive or negative charges make up this lattice. And so what water does, due to the fact that water is polar, whoa, that was weird, it can wiggle its way in and actually get in between the ions based on its polarity. It's got that ability. So if we have a water molecule, you really need to get used to drawing it with its partial charges. The oxygen side, because oxygen is more electronegative, is partially negative. And then the sides with the hydrogens are partially positive, okay? So when you draw something dissolving, the ions are going to be solvated with a solvation, kind of a cage around them of water, and the actual water molecules are going to face appropriately. So we have our really big anions in this picture, and then we got our small cations. So how is water going to orient itself around the negative anions? What side of water is going to be attracted to that? Exactly, the side with the hydrogen. So you're actually going to get this solvation of the ion with the water facing this way. And this is literally what they expect. Like, there are questions on the AP where you have to orient these specifically, and they'll even give you sometimes using no more than 5 H2Os and no less than 1, blah, blah, blah. And so they're giving you very detailed instructions on the expectations of these particular diagrams. So that would be how you would surround an anion. Okay? And then how would water be solvating that cation? The opposite. Our oxygens would be facing the actual cation. And so we're solvating in that way. Okay? So this is very clear for your ions because these are separate charges, all right? So if you have a molecule that's polar, so say we have a molecule that itself is polar and has a negative end and a positive end, the solvation would kind of be split. So you'd have more of the hydrogens facing this side of a molecule. And this is a molecule that doesn't dissociate into ions. What would be a polar molecule that dissolves but doesn't make ions in real life? Give me an example. Kate. Yeah, sugar. Perfect. Glucose, any sugar dissolves, but it doesn't ionize. Okay? So with these, you'd have the molecule itself would have water solvated a little bit differently because there's no split in positive and negative. Okay? So being that this is polar, it could still dissolve, but it's not going to be separate ions like the ionic or covalent. On the AP so far, I've only seen them have you do solvation and dissolving and solvation pictures of actual ionic compounds. I think this would be too iffy to grade. That's just my prediction, but I don't know. I haven't seen one yet. Okay, so let's start with talking about strong, weak, and non-electrolytes. In order to be an electrolyte, well, first let's define electrolyte. What is an electrolyte? It's a solution that what? Well, what does it do, though? What do the ions allow for it to do? Conduct what? Electricity. So an electrolyte is a solution that conducts electricity. So a strong electrolyte is a solution that 100% everything in there is ions, and electricity is going to be highly conducted. We do have something called weak electrolytes, where we've got a few ions in there with different molecular species, and a little bit of electricity is conducted, and then we have non-electrolytes. So in order to conduct electricity, we need ions. That's the key. All right? So what kind of things conduct electricity? Give me some examples. On the last page, what were we solvating? What? NaCl. What is NaCl an example of? An ionic compound. And it's more specifically a soluble ionic compound. If it's a soluble ionic compound, it is going to dissociate 100% and be all ions. So ionic compounds that dissolve will dissolve 100%. Which ones don't? We have solubility rules that we're going to look at in a little bit, okay? And those will usually be weak or non-electrolytes, but if they don't dissolve. But if they dissolve, they conduct electricity. What else dissociates or ionizes pretty regularly? There's a group of a couple things that you already know exist. Naira? Where does that? Yeah, hydroxides. But what is that? What kind of compounds does that come from? Bases. So what kinds of bases? Strong bases and strong acids, exactly. So strong acids and bases, that was, everyone like added a new word, 3 people, that was kind of cool. Strong acids and strong bases, by definition, they dissociate 100%. The acids dissociate into the H plus whatever cations attached. And then the strong bases has that hydroxide given off along with its cation. So those things dissociate 100%, and those are examples of strong electrolytes. Weak electrolyte, or non-electrolytes are your polar substances that actually dissolve in the water. And not even polar. We can try to conduct electricity in oil. Oil will not conduct electricity, right? Because what does oil, glucose, what do they not do? Why won't they conduct? They don't dissociate into ions. So any covalent substances, any covalent substance is going to dissolve. Well, if it's polar, it'll dissolve in water, but it won't ionize. Okay? So covalent substances, and by that, things with nonmetals. So C6H12O6 is an example. What else is an example? Oil, right? Carbon dioxide, when you put it in water, conduct electricity? No. Does water conduct electricity? Pure water. Well, why can't we get in the pool then when it's raining? Isn't it, thunderstorming? Yeah, there's ions in the water. When in that thunderstorm, we're not afraid of the water. It's all the ions that are dissolved. And the second you get in, you start giving off ions. So it's really tough to be in a pool of pure H2O. So H2O, pure H2O does not conduct electricity. So now that we know strong and non, what would be an example of some weak electrolytes? There's really only 2 things. Potentially an ionic compound that doesn't dissociate completely. I'm not going to write that down because that's going to be one that we're not going to really focus on. There's another set of things that you know. Yeah, weak acids and bases. Weak acids and weak bases. They dissociate, whoa, it's magic. Those things dissociate partially. So only a few H pluses jump off and only a few OH minuses jump off the ion, their partner ion, and they have very, very low conductivities. They have some, and conductivity is a measure of how strong an electrolyte is. If we say, oh, it's very conductive, it has a high conductivity, that means it's a strong electrolyte. Okay? All right, now we're going to classify. We've got a list here, and I want you to tell me if it's a strong electrolyte, a weak, or a non. But before that, let's go ahead and review how to classify a strong acid. So there are 3 strong binary acids. By binary, I mean it's got 2 things in them. Does anyone remember what those are? HCl, HBr, and HI. So the way I taught it is, we know that diatomics are I bring clay for our new house, right? Well, the binary acids that are strong are just I bring clay. So I bring clay. I bring. Those are my 3 strong binary acids. Now with ternary acids, we had a little rule of thumb. The things that have polyatomics in them. How did we determine if something was strong? Was that ratio, Naira? Exactly. You have to have 2 or more O's than H's. 2 or more O's than H's. So for instance, if we have HNO2 versus HNO3, HNO2 only has 1 more O than H, so this is going to be weak. This one has 2 more O's than H's, 2 or more, so it's strong. And any acid with a C, any carbon anywhere in the acid makes it a weak organic acid. Okay? So if there's a C in it, don't even look at the O's. It's weak. What about bases? Mostly bases contain what? Hydroxides, right? So, which hydroxides are strong? Which ones dissociate? Your group 1 and the bottom of group 2. So the strontium and barium ions, group 1, strontium and barium hydroxides, those are all strong. Any other base is going to be weak. Your nitrogenous bases, all your amino acids, your ammonia, amino acids aren't bases. Take that back. Your ammonia, your nitrogenous bases, these are all weak. So if it's not one of these, and you know it's a base, if it's not a group 1 or a strontium plus 2 or a barium plus 2 hydroxide, then you know it's going to be a weak base. Ammonia is the consummate weak base. Not ammonium. What's ammonium? NH4 plus, and what does that participate in? What kind of bonding? Ionic bonding. So if you see an NH4 plus, that's not even in the acid-base category unless you're talking about Laurie Bronsted. We look at that and we treat that in an ionic compound as if it's a soluble thing. Okay. So let's start with the first one on the list. HClO4. Let's classify that first. What type of compound is that? Specifically, a strong acid. There's 2 or more O's than H's. So strong acid. Strong acids are what kind of electrolytes? Correct. So this is a strong electrolyte. It says in the instructions, if strong, write the dissociation. Don't forget, when things dissociate, they split into their constituent ions. What would that dissociate into to become ions? Nice. H plus Cl. Okay, y'all gave me hope again. Last period, nobody knew the answer to this. I got really kind of flustered. All right. C6H12. What kind of compound is that? Is it an acid? No. Covalent. It's a covalent compound. This is covalent. It's not an acid. It's not ionic. It's covalent. And so what kind of electrolytes are covalent compounds? They're not even weak. They're non-electrolytes. So that will not dissociate into ions. Okay, what about LiOH? Strong base. It's a group 1 hydroxide. Strong bases are therefore strong electrolytes. So if I want to dissociate that into ions, what does it do? What two ions will this make? Li plus, and that's what will make it conductive and make it be slightly conductive. Not slightly, very strongly conductive. NH3, let's classify that. That's a weak base. So what kind of electrolyte is that? Weak. Okay. Sodium chloride, what is that? Ionic. Is it a soluble ionic in solution in water? Yeah, have you been in the ocean? Yeah. Maybe, maybe not. But yeah, definitely. So what would the dissociation equation be? Plus Cl minus. Okay, this next guy, what is this guy? What's its name? It's H in front of acetate, so it's acetic acid, and that is a weak. Why? Carbon in it. It's a weak acid, so this makes it a weak electrolyte. Now this is just something, you can write this down, I just want to show you the difference. Weak electrolytes do have ions form, just not a lot of them, and so they have the same kind of dissociation equations, but there's a slight difference to those. Can anyone see the difference in the equation I just did? Yeah, this double arrow is saying, hey, not all of it's in ions. Actually, most of it's going to reside in its molecular form here, and you get a few ions, and that's why we have some ions floating around to give us a weak conductivity. Okay? So all these strong things have arrows that go to completion. The weak things, not so much. All right, the last one. Don't let this one trick you. NH4Cl. It's all nonmetals, but what? How are those held together? Yeah, they're held ionically because NH4 plus is an ion. Okay? So, since it's an ion, we are going to say that, and this, there is a solubility rule that says all ammonium-containing compounds are soluble. So these 100% split up. They're soluble, so that makes this a strong electrolyte due to the fact that it is ionic. So what would the dissociation equation be for this guy? NH4Cl goes to completion to make what? NH4 plus and Cl minus. Okay? All right, that is it. Today's lesson is super short, so you can enjoy your no homework night. A lot of fun. And we will pick up tomorrow with solutions and molarity.